Let's take a look at how to solve what I call a two-step variation problem. We actually did problems like this way back when we studied direct variation. These are going to be the exact same idea, just with a brand new model. This time we have an inverse variation relationship. So if you recall from our previous video, if you watched that one, the inverse variation equation is y equals a divided by x. So let's go ahead and take a look at how one of these is going to work. So beginning with that model, the inverse variation model, I know to use that because they say that x and y vary inversely. They're going to give you a couple numbers to plug in, and our first step in the two-step problems is to write an equation. So let's plug in the values that we have. They tell us that y is 7 when x is equal to 4. We're going to try to find a, the constant of variation. That's going to be my first goal. So setting this up and then multiplying both sides by 4, I get an a value of 28. So my constant of variation is 28. Now that's not the answer. That's going to be part of my answer, but it's not my final answer because we want an equation. When you write one of these inverse variation equations, or any variation equation, there will only be one number in them, and that's going to be the a value we just found. So replacing x and y, or plugging y and x back in for y and x, I end up with my equation of y equals 28 divided by x. So there is my equation with, again, only one number plugged in for it. That's going to be the constant of variation we found. Step 2 then is going to ask us to use this equation. So they'll give you some more values, or in this case just a single value, and they ask us to find y. Now sometimes they may ask you to find x, so just be careful that you read carefully, I suppose. So let's plug in what we need to know. So using the equation we just found, to find y, I'm going to take 28 and divide it by what x is. So in this case, x is -2. Dividing that out gets me a y value of -14. So that's how I solve these two-step problems. Step 1, write the equation. Step 2, use your equation. When we get to an application question, it looks like it may be more difficult just because it's a word problem, but watch how this is the exact same thing we just did. In this case, I have the number of songs an MP3 player can hold varying inversely, so there's my keywords telling me to use that inverse variation model. It varies inversely with the average file size. In other words, if the file size goes up, the number of songs I can hold go down, which makes sense. If the songs are bigger, I can't hold as many. So step 1, remember, just like last time, is to write our equation. So let's use our inverse variation model to do this. And again, watch how this is the exact same thing, just with words wrapped around it. So in this case, my inverse variation model is y equals a times x. What I'm going to do though is switch out the variables just so this makes a little bit more sense. And my advice is to put the variables down in the order they appear in the problem. So first up, they talk about the amount of songs. So I'm going to call that s in this case. So instead of y equals, I'm going to say s equals. A is just a because that's my constant variation. And what it varies inversely with is the average file size. I'm going to use the variable f to represent the average file size. So rather than y equals a over x, I'm going to use s equals a over f. Now you don't have to do it that way, but I think that makes a lot more sense, especially so we can remember what our variables stand for. So just like step 1, they're going to give you some values to plug in for s and f in order to find your constant of variation. So they tell us that we can hold, or our iPod or MP3 player can hold 2,500 songs when the average file size is equal to 4. So let's plug in the values they gave us, just like in the last example we looked at. Multiplying by both sides by 4 gets me an a value of 10,000. Now remember, that's not your answer. They've asked for an equation, so this will be part of your answer, but not the equation itself. Your equation should have one and only one number in it. That's the constant of variation. So the number of songs we can hold is equal to 10,000 divided by their average file size. So there's my equation, just like we did last time. Step 1 is done. For step 2 now, let's go ahead and use our equation. So this time they ask us how many songs can it hold if our average file size is increased to 5.5 megabytes. Well, even before I answer that question, here's what I want you to think about. Since my average file size has increased, it's gone from 4 megabytes up to 5.5 megabytes. Since that's gone up, the number of songs that I hold should go down. It should be something smaller than 2,500. So I'll know if I get something bigger, something's gone wrong. So let's see what happens. The file size, or the number of songs I can hold, is equal to 10,000, just like step 2 in our last example. I'm just plugging in the information they've given me. So 10,000 divided by an average file size of 5.5. Using a calculator to do that, I end up with a decimal. You guys can pause the video and try that for yourself. But I need to think about rounding and what it would make sense to round to. Since S stands for the number of songs my iPod can hold, I should probably round that to the nearest whole number, which in this case is going to be 1,818 songs. So just like we predicted, because the file size went up, the number of songs we hold went down. And as I said, it's the exact same thing that we just did. Step 1 was write our equation. Step 2 was use our equation.